Let's take a look at how to do Lewis-Dot structures for a little more complicated molecules. Okay, when we have this type of molecules here, CH3CCN, first of all, the first thing we need to do is determine the total number of valence electrons that is available to us. Hydrogen will only have one electron, and there's 3 of them, so I have 3 electrons from the hydrogens. And then the carbons, I have 2 carbons. Each carbon has 4 electrons, which gives me a total of 8. And then nitrogen, one nitrogen, has 5 electrons, so one nitrogen gives me 5 electrons for a total of 16 electrons. Okay, now I have to distribute these valence electrons equally around all of these. We already talked about the fact that hydrogen cannot be a central atom because it can be a terminal, meaning it bonds at the ends of a molecule because it can only bond once. It has only 1 electron. Therefore, my hydrogens here cannot be in the middle. So I can't have something like this, where I have a hydrogen in the middle bonded to the carbons, or a nitrogen up here, another hydrogen, etc., because it can only form one of those lines. It can only form one bond. However, we talked about the carbons that can form up to 4 bonds. Therefore, a pretty good candidates to being in the middle would be these carbons. And just the way they're bonded kind of gives you an indication. So let's start to bond. Here's my carbon, here's my other carbon, and let's bond it to the nitrogen and then go from there. Now, this carbon here could be bonded to my 3 hydrogens, just like so. And that way my hydrogens are terminal. You see they're not bonded to any other elements or any other atoms. They're called terminals. And they're happy because they have 2 electrons. Each line represents 2 electrons. So now let's count the number of lines. 2, 4, 6, 8, 10. That means I have still 6 electrons to deal with. Now if I look at this carbon right here, it has 2, 4, 6, 8 electrons around it, which means it has a full octet. This carbon is happy. But this carbon has 2, 4, which means it needs 4 more. And this nitrogen only has 2, so obviously it needs more than that. Now, there's a couple of ways you could do this. We would know that those 6 electrons would have to form double bonds somehow, because I don't have enough atoms to bond around all of these. So if I double bond, I put 2 bonds, so 4 electrons between this carbon and this nitrogen. That means that this carbon has 2, 4, 6 around it. It needs some more. Now it can't bond anymore to this carbon because this carbon's happy. It has all of its bonds. It's got its octet. So this carbon has to continue either bonding with the nitrogen or having a lone pair. But since the nitrogen isn't happy with just 4 electrons around, I would say they have to share a little more. So now this carbon, let's count how many it has. 2, 4, 6, 8. It has 8 electrons around. So this carbon's happy. But this nitrogen, let's count. 2, 4, 6. So each of these lines stands for 2 electrons. It's got 6 electrons, meaning it needs 2 more. And because it cannot bond to this carbon anymore, because this one's happy, it can have those 2 electrons as a lone pair on its own. Now, let's count the electrons around it. 2, 4, 6, 8. So this one is happy. The last step that you have to make sure that you do is not only are all of my elements happy with the way I've connected them and the way I've distributed the electrons, but I also have to figure out if I've used all of my electrons. You cannot use any more and you cannot use any less. So we have to count to make sure that there's 16 electrons dispersed throughout this molecule. 2, 4, 6, 8, 10, 12, 14, 16. That is the correct number of electrons. I've used them all up, and therefore this is the correct Lewis-Dot structure for this compound. Now let's take a look at this one. I still have 3 hydrogens, which means that I will have 3 electrons that are coming from the hydrogens. Now I have 1 nitrogen, which, as up here, we have 1 nitrogen, which contributes 5 valence electrons. And then I have an oxygen, just 1 oxygen. It looks like 10, but it's oxygen. And it contributes 6 electrons. If I add all of these up, I will get 14 electrons total. Those are the electrons that I need to use, no more and no less. Okay, well, let's take a look. Once again, my hydrogens have to be terminal. They cannot be middle atoms because they can only bond once. Therefore, my other 2 elements that are left would be the nitrogen and oxygen. So I would assume that the nitrogen and oxygen would be bonded to each other. Now, because this hydrogen is written right next to the oxygen, I would assume that this one is bonded to the oxygen directly. And then these 2 are bonded to the nitrogen, and I'll bond them at an angle not to mess up this one. All right, so now let's count the electrons around. I've used 2, 4, 6, 8 electrons. I have to use 6 more. Let's count the electrons around the nitrogen. 2, 4, 6. It needs 2 more. What about this oxygen? 2, 4, it needs 4 more. Now, if I were to be tempted to write a double bond here to get my nitrogen happy, 2, 4, 6, 8, my nitrogen's happy. My oxygen is 2, 4, 6, which means that it will have a lone pair, 8, okay? If I were tempted to make a double bond here, let's take a look. Okay, well, my nitrogen is happy because it has 8 electrons. My oxygen is happy because it has 2, 4, 6, 8 electrons. Hydrogens are happy because they have 2 each. Let's look at the total number of electrons. I need 14. 2, 4, 6, 8, 10, 12. Oops, I have 2 more electrons to use. That means that the nitrogen and the oxygen cannot share a pair of electrons. Okay. All right, what do I have now? 2, 4, 6, 8, 10. Remember in that slide where we talked about the oxygen forming 2 bonds and having 2 lone pairs. So pretty much every time you see an oxygen in general, it would either have 2 bonds and 2 lone pairs, just like this, or oxygen can also have 1 bond and it will have 3 lone pairs. Or it could have a double bond, right? This is 2 single bonds. It could also have a double bond with 2 lone pairs. These 2 are the best configurations for oxygen. This, if it's necessary, but oxygen prefers to have either a double bond with 2 lone pairs or 2 single bonds with 2 lone pairs. Now that I've satisfied my oxygen because it has 2, 4, 6, 8, I have to figure out how many more electrons I need. So 2, 4, 6, 8, 10, 12. I have 2 more electrons. Remember that my nitrogen is not happy because it has only 6 electrons. But if I put that lone pair on the nitrogen as well, now I have used up all of my electrons and all of my atoms are happy. Nitrogen has 8, oxygen has 8, each hydrogen has 2, and therefore this is the correct formula, the correct Lewis dot structure for this particular compound.